Okay, so let's see. Good morning, everyone. My name is Suka Hong again. Uh, I'm associate professor in data science and business analytics. So actually, I have two heads. One is in data science and one in business. For my master's, I did stochastic optimization, contract optimization. So I did a lot of operations research stuff. So I do like a lot of math, statistics. That's what I used to do. But I got my PhD from Virginia Tech in business. So I also have some experience in social sciences as well. So you may think this natural language processing, ChatGPT, large language models might be an area for either data science or computer science, but it's not totally true because we are trying to create an AI which is an entity that might serve like a human. But there is also a component in social science that we also need to study AI for our research and for our teaching as well. So today I'm going to talk about how language models work. Okay? And based on that, we'll try to build like a simple custom chatbot using either non-programming approach and with the programming approach. So I'll show you both of them today for all the audience in the meeting. So the agenda today will be, I'm going to show you how the language models work in general. So introduction to large language models, and I'll talk about what are the strengths and the weaknesses of large language models. And then we'll go to chatbot, which is based on the RAG, which is a retrieval augmented generation. So I'll talk about RAG. I'll show you how RAG works. And I'm going to demo three of them. One will be Copilot, which is a service provided by Microsoft. And also ChatGPT, which everyone knows. So I'll show you how you can create a custom chatbot using ChatGPT. And finally, we'll use some Python. I'm not going to teach you Python today, but I'll just show you how you can create a custom chatbot using Python and some of the open source large language models. So basically, it's going to be free. Okay? And of course, Q&A. So here, this screen here, this one slide tells you what a language model does. Right? A language model learns to predict the probability of a sequence of words. That's it. Right? Either ChatGPT, Google Gemini, whatever the language model that people talk about right here. What it does is just one thing. It predicts the probability of a word given a sequence of words. That's it. Right? It's very simple. That's all. So why is that important? Why do we have to assign some probability to words or language? Say we are doing machine translation, right? So you are building a system that takes words from one language and try to convert it into another. Right? That's your goal. That's what machine translation is. There are multiple possible translations, right, that can be generated. How do we know which one is most accurate? Right, so using this probability actually tells us, given a sequence of words in one language, what will be the best translation in another language among all those possibilities? Okay, that's why we need a probability for language. Here, same thing. So if you look at the small figure on the right, it says the cat is small. That's one sentence. And the other sentence number 2, which is small, the is cat. Right? Unless you are watching Star Wars movie, which Yoda is in, you will see that the probability of you seeing the sentence on the left, the cat is small, is obviously higher than the probability of you seeing small, the is cat, the sentence, you seeing that on any documents. Right? So that's how the probability works. The probability basically describes what is the likelihood of you seeing the sequence of word in any documents. That's it. Right? So there are basically two types of language models. Right? One is statistical language models. The other one is neural language models. And of course, most of the language models that you talk about right now, ChatGPT, Gemini, are neural language models. But I'll use a statistical language model as an example to show you how this language model works. So here we have to first define what an n-gram is. N-gram is just a sequence of n words. That's it. Right? So the n describes the length of the sequence of words. So if you have 3 words in your sequence, it's going to be a trigram. So take the sentence, the cat sat on the mat, right there. The unigram, right? By 1 gram, or we usually call unigram, is just a single word sequence. They are the cat sat on the mat, right? So all this single word sequence. Bigram, on the other hand, is just 2 word sequence. So the cat sat on the mat, right? So we have a lot of bigrams in the same sentence. Trigram, again, the cat sat, trigrams are the 3 word sequence. The cat sat on the mat, right? So you get the idea, right? So quadrigram will be a 4 word sequence and so on. That's just an angle. So we use this to create a language model. So how the n-gram language model works? Okay. An n-gram language model predicts the probability of a given n-gram, say trigram. So you'll be given 3 words sequence. So in this example, will be a quadrigram language model. So you'll be given 4 words sequence. Can you please come? And what the language model does is it's going to try to predict the probability of word here or any word that should come after this 4 word sequence. That's all it does. Right? So you will have all the word in your vocabulary in English, and the n-gram language model has probability of each word appearing right after "Can you please come?" of all the word in your English dictionary. That's it. As simple as that. Right? That's what it does. It just has a bunch of probabilities for each word in your vocabulary, given a sequence of words. That's all. So of course you can do trigram language model, you can do bigram language model, and so on. Right? So the probability of the word here that will appear after the sequence "Can you please come?" is actually a conditional probability. So I need to do some statistics today. I've tried to stay as simple as possible, but you can see the probability of you seeing the word here given the 4 sequence word "Can you please come?" This is a n-gram language model. That's already. Okay. So there are some statistics behind this, but say you have a n length sequence, and you are trying to predict the probability of words that will appear after that n length sequence. Right? So it's going to be probability of you seeing n plus 1 word given probability of you seeing the first word, probability of you giving the second word, third word, fourth word, all the way to nth word. Okay? This is order. And there is like in Markov chain, there's like a chain rule and so on. You can actually simplify this too. Instead of using all the things in here, you can just estimate this probability as probability of n plus 1 word given the last word. Okay. So by doing this simplification, you can come up with this n-gram language model. Of course, the ones that we use right now doesn't do this simplification. It actually takes all the words in your sequence and try to come up with this conditional probability of the word that you see after n sequence of word. That's what language model does. Very simple as that. Nothing fancy, just simple statistics. Okay, right here, more details. I'm not going to go over all the details. Again, to sum up, right? A language model defines a probability distribution over word sequence. So given a word sequence here, again, for word sequence I want to that will be your given word. I'm trying to predict the word that will come after this four word. So that's the probability right there. Fifth word given those four words. That's all. Okay? And the interesting thing about this language model is it actually has generative capabilities, which is given this probability, you can, given a sequence of words, you can actually come up with the word that will most likely appear after this four sequence of words. Right? That's where the generative AI or this ChatGPT becomes a little bit interesting because you can use this probability to generate a word, or it could be a sequence. So now, how does that work? If you put something in ChatGPT, what it does is whatever you put there will be this given sequence of words. It's called context. Right? Given whatever you put it there in the ChatGPT, it's going to try to predict or calculate the probability of word that will most likely appear after your prompt. Right? And it selects the one that will be most likely, that has the highest probability of appearing right after your prompt, your context. So it generates one. Say you have, I am a boy. No, I have Koreans use this sentence a lot in any examples. This is your prompt. What ChatGPT does is, given this, it's going to try to predict, okay, so what will come next? Right? So it will have all these probabilities, and it's going to select the word that has the highest probability given this four words. So I am a boy, maybe A. Right? So the model selects this. Now what it does is this whole thing becomes your given sequence, the context. Now what it does is, given I am a boy and, now you have a 5-word sequence as a context, and it's going to try to predict the word, the 6th word. It will probably like to appear after whatever that is. Right, so it continues. Now, given the 6th word, I don't know, there could be a 6th word, and it's given this, it's going to generate the next word, maybe like, and given that until it's going to get this end of sentence, US, that is passed. So there is a probability of end of sentence, so ending the generation in the model, so it knows when to stop. That's how ChatGPT works. That's all. Nothing fancy, nothing complex. It just generates the next word given the sequence of words. That's what it does. Okay? So very, very simple. But you can see ChatGPT does a lot more than this, right? So you might wonder, okay, if this is all it does, how come it's so smart? Okay? So everyone wonders that. Again, here some. A good thing about this, the large language model, these language models, is that it can be scaled. So meaning you do not have to change the structure, architecture of those language models, or you can just make it bigger. You can add more parameters, you can add more layers. You can just make it really big without changing the architecture. And right there, that's what it says. And that's why we are now call it large language model, because we just made it really big. That's all we did, right? It's just a language model that does what I just described in here, predicts the word that comes after a sequence of word. We just made it really big, right? And we trained the model with the really large data set. That's all we did. We didn't change any architecture from the language model that developed a couple of years ago. All we did was just increase the size, make the training data larger, put it there, and see what the large language model does. That's all the OpenAI people. Of course, there are more things that people did, but basically, fundamentally, that's what they did. Right? They took the language model that I just described, and they just make it very big. And suddenly, when people start to make the language model bigger, they start to see or experience these remarkable abilities in large language model. It's called emergent abilities in large language model. All we did was we just increased the size of the model, and we just gave the model more data to train. More data meaning the model just reads more documents, or the web pages on online. That's all it did. We gave the model more data, a little bit bigger brain, we'll say, because it has more parameters. And suddenly, people who work with this language model start to experience this amazing abilities that people talk about right now. Right? So people use child brain development process to describe it. So, I was born in Korea. So my first language is Korean. When I was in high school, my dad moved to Hong Kong. So when I was like 16, 15, 16, I moved to Hong Kong and I went to Canadian International School. And of course, they speak English. So I didn't know any English sentence at the time. So I just sat there at school, which speaks English, for about 6 months. And I didn't know what the teacher's saying. I don't know what my friends were saying. Just sat there doing nothing for 6 months. That's all I did because I didn't know English. After 6 months, suddenly, I don't know why, but I started to understand English. I don't know why, but just one day I went to school, just like the other day in 6 months. I started to see, oh, that's what the teacher is saying. I started to get what the teacher was saying, and that's how people describe this emergent abilities in large language models. Suddenly, as you increase the size of the model, the ability appears. Okay? So that's the consequence. Well, why? Why? I mean, we like to know why. So we just increase the size of those language models to large language models, and suddenly all this amazing abilities appear. People use physics to describe again, like so the child example or this one. At 0 Celsius, right? Or higher, the water molecule is in liquid phase, right? It has the characteristics of liquid, and as soon as the temperature hits 0 Celsius, it starts to become a solid. The characteristics become solid. So that's how people describe the emergence of those abilities in language. So here, a little bit more formal definition. The emergence can be defined as the sudden appearance of novel behavior. Large language models apparently display emergence by suddenly gaining new abilities as they grow. So I love this one. This is actually not mine. It's from the paper right there by Google Research. So it kind of shows you how the size of the language model increases. What are the emergent abilities appear as they grow? So in the beginning, you just have a language understanding, question and answering. And as it becomes bigger, you can do as complex things as common sense reasoning and so on. So I love this tree picture example. So one of the emergent ability is cause and effect, right? So cause and effect differentiation. Large language models can identify a relationship between actions and outcomes. So you give a large language model two sentences. I got an A. I studied hard and I got an A, right? Or you can give the LLM. I got an A and I studied hard, right? And I asked the language model to guess which sentence is correct, and the large language model is able to guess that I studied hard and I got an A. So it is able to differentiate cause and effect. It also does reasoning, right? It's called chain of thought. So you break down a task into series of tasks, and in the end you start to reason as a sequence of tasks. I'm going to explain this in a bit, but this is actually why some people think that this emergent abilities appear as the large language model becomes larger. Okay? So I'm going to talk about this again, but this is super popular topic that everyone talks about, especially when OpenAI just released their latest model, Strawberry. I think that's what they call. But that's you will see. It says it's thinking, it's reasoning. It all comes from the chain of thought. So I'll explain in more detail. And one of the emergent abilities is it is able to understand the jokes and make one for us, which a couple of years ago, no one thought any language model can do this. It is able to explain why the joke is funny. And this, I think, is the most popular area where people use a large language model is to write code for it, the programming. That's how one of the most popular application of large language. And you will see it's extremely good. It is even able to fix all these errors in your script and make it run. So here, this is what people think that these emergent abilities appear as the large language model becomes large, right? So take this probability. So it can be a micro level probability P, or it can be a macro level probability P. So micro level probability P is, say you enter the prompt in ChatGPT. This is your prompt, right? And it's going to guess the word that will appear after your prompt. That's your first one. And the second word, third word, and so on. It's going to generate it. So, but there is a difference between generating a correct word given your prompt, right? That's a totally different thing. So let's say probability of P is the probability of your language model comes out with the correct word given your prompt. Right? And in order to have your answer correct, say this is your answer in M sequence of word, the language model has to get all the word correct to get the answer correct, right? So here P is just a small probability of guessing the correct word given the prompt. Getting the correct answer is a lot more difficult task because the language model has to guess M sequence of word. And of course, that's a joint probability, meaning the first word has to be correct, probability of P. And the second word has to be correct, the probability of P. If the model fails at any stage, the whole thing fails. It just fails to generate a correct answer, right? So you have to be correct all the way up. P, P, P. So it's basically going to be P power to N, right? And if you look, here's a brief example. If the probability of the language model guessing the next word is 0.1, even with the 10 sequence of word as your answer, the probability of the language model getting the answer correct becomes 0, even with the 10% chance of getting the next word correct, right? Even with the 50% of chance of guessing it correct, 0.5, short answer like 10 sequence of word, the probability of the model perfectly guessing or coming up with the correct answer given your prompt becomes almost 0. Right? And as P increases, look, even 0.9 10 sequence of word it's less than 40%. As it starts to become 0.99, the probability of the model coming up with the correct answer, given your prompt, becomes over 90%. And then, of course, with 0.999, it becomes almost 99%. So this is how people explain, as the language model becomes larger, how those emergent abilities appear. All it does, as the language model becomes large, it increases this P. Right? Small model becomes 0.1, P of 0.1. I don't know, like 1 billion parameter model becomes 0.2. As it increases, like ChatGPT 3.5 becomes, I don't know. I don't know the probabilities because they never tell us, but maybe it becomes 0.99. And suddenly, for a specific task, 10 out of 9, the model start to get it right. And we feel it, right? We can experience it. Actually, the probabilities, people can feel it. We can experience it. So if we play with these language models, actually, I played with GPT-2 or old version, even before GPT, with GPT-Bart and those things. The probability of the model generating a correct is different from something that is readable. Yes, the language models will definitely generate a sentence that will be readable, but that's totally different from getting a correct answer. So if you play with the early version of those GPTs, this is very poor. It generates a sentence, but it just doesn't make sense at all, right? But if you play with the ChatGPT 3.5, that's when people start to pay attention to those GPTs. As it does make sense, and it gets most of the answers correct, right? And this is the micro level, macro level too, right? So you generate a sentence correct, and you can generate the next sentence correct. So the probability of the model generating all the sentence in the paragraph correct increases. And when people start to fill it with the high probability, that's when they say, oh, now this one specific ability appears. Okay, so say computer programming requires 30 steps of this things getting correct, P of power to 30. It doesn't appear until P is high enough, right? And suddenly P becomes high, then you can feel, oh, more than half of the time that this language model gets my Python code correct. Right? That's how the emergent ability appears. Translation same. So it's all based on the experience. So if we just play with it, people say, oh, it's amazing. This is amazing. Language models are amazing. It suddenly started to do a lot of things that we never thought of. They suddenly appeared. But if you look into micro level, all it changed as the size of the model increased. It's just 1P right there. Okay? But it makes huge difference to us because we can feel it. So what does this all mean here? The problem with this is uncertainty in scale. So in order for one specific ability to appear, we don't know how large the language model should be because we never expected them to come at this point. So we don't know. We just don't know, right? It has to be 1 trillion parameters in order to see whatever the ability that we like to see in language model. We don't know because it appeared out of sudden. So we don't know when it's going to appear. So we don't know, right? And uncertainty in ability level. So we don't even know which ability will appear at what size as we increase the size of the large language models. Okay? So we don't know when it appears. We don't know what will appear. Okay? So we actually know nothing. We just increase the size of the language model and hope, oh, maybe next time we'll see these abilities in the language. But that's what we can hope for. Okay, so given those, so there are a lot of discussions there. Is abilities fact or illusion? This is interesting conversation. But I mean, we cannot deny that those abilities actually appear in large language model. But that's how we do. We humans actually, when we reason, it's not like one-shot reasoning. As the task becomes complicated, we use this multi-step reasoning. So we go one step at a time, right? And that's just like how AI works. So where do we go from here? Why not increase the model as large as we can make? Because in physics, those are particle collider, right? Which is size of a city. They can study the molecules and so on, atoms, so on. So people say, okay, so let's increase it as big as possible and see what it can do. But that's just not possible. So early in the time here, this is a slide that I actually used in my class, and this is actually 2 years ago when GPT-3 first came out. So GPT-3 has how many? So I played with GPT and it had 1.5 billion parameters, which was released 2017 June. It wasn't good. Things that it can do, of course, it can generate the text. That's what language model does. It does a very low quality language translation, and it does some of the text summarization. That's what first version of GPT did in 2017. And we kept the same 2019. We changed the architecture a little bit, and we came up with GPT-2, 1.5 billion parameters. It does the same thing as GPT-1. A little bit better because we didn't increase the size of the model, so it stayed the same. GPT-3, that's when people start to talk about all this generative AI. GPT-3 released June 2020 with 175 billion parameters. And then people start talking about, oh, AI is coming. We'll probably be slave of AI soon. AI will do most of the work for us. So that's when people start to feel that GPT is a lot better. I mean, a lot better than they expected. And at the same time, ChatGPT came out, right? 2020. It was just mind-breaking for many people. And the picture here, this circle thing. So I create this chart when GPT-3 first came out. So if OpenAI keeps the scaling of GPT-2 to GPT-3, so GPT-3 is 175 billion. We expect the GPT-4 to be what? What is this? How large is this? In the beginning, we expected it will have 100 trillion parameters. That's what I expected. So we were super excited when GPT-4, if GPT-4 came out, 100 trillion parameters. Think about things that it can do. Right? But actually it came out, if you look at this one right here, the GPT-4, the size of GPT-4 is just 1 trillion. Right? So it's not even half the size. It's like 1/100th size of what we expected. So GPT-4 is good enough, we can feel that, but you can definitely see how difficult it is to increase the size of the large language models from here. So people say we almost hit the ceiling. I don't think we can do any bigger than this because, of course, to create these language models, as it gets bigger, you need to buy a lot of GPUs. You need to use a lot of power, time, data. and so on. So there are so much limitations there. So we might not be able to increase the size of language model to 100 trillion. So we'll never know, right? We'll never know soon. I mean, what are the abilities that the AI can do if we increase the model to 100 trillion parameters? I mean, we'll never. We'll know, but not soon. Okay, so there's a other thing that OpenAI did. In addition to increasing the size of the model, you'll be surprised that OpenAI hires hundreds of people, not computer programmer, not data scientists, or not researchers. They just hire people. What they do is they just use these GPTs that OpenAI has developed. And actually, the model produces several responses. We just see the first one, the best one, but it actually generates, because it's a probability, right? So it will give you some alternatives, which has a slightly less probabilities according to their model. So what these people do, they pay a bunch of money to these people. All they do is they see this 4 or 5 responses that the model generates, and they just choose the best one. That's all they do. They just test it whole day, put something in, and look at the response that the AI has generated, choose the better one again and again, and the model is trained on the data that you provide. So it knows, you start to learn, oh, okay, so this answer, given these 2 answers, this is what people prefer. I'm not saying it's a better one, but that's what people prefer. Right? So they paid a lot of people to do this. Okay? And the more interesting thing is that OpenAI has to pay these people, and they're expensive. So what they did is they built a machine learning model that studied, that learned what people prefer. Right? So instead of using human, these OpenAI researchers create a model, like input all this feedback from human, trained it, so the model knows what we will prefer. So instead of using people, OpenAI used this model to test their language model again and again, really cheap, really fast, and improve their model. That's what they're doing. So I'm not sure you can see it, and it's even in Korean. If you use the free version of ChatGPT, at the bottom it will say, do not share the sensitive information. Your chat could be, I don't know, could be used to train the model. Right? So if you use a free version of ChatGPT, and you'll get this screen right there, like this one. It's going to show you like 2 or 3 responses, and it's going to ask you which one is the best one. So you are doing this work for them if we're using the ChatGPT for free. If we use a paid version, it has a different warning sign right there. It says your workspace training is not shared and it's not used for training the model. So you rarely get this screen because you are paying for the model. So you may think, oh, okay, I'm using ChatGPT for free, and it does exactly the same as what the paid version does. But actually, you're doing some of the work which is quite expensive for the OpenAI. Your responses, whichever you select, they use to make their model better. Okay? So there's nothing free. There's no free lunch there. So due to all these characteristics of a large language model, there are obviously limitations. People talk about how amazing large language models are, but we rarely talk about the limitations. But you have to know that in order to use the language model better. First one is that the language model cannot process everything at once. Right? So by this point, you know how the language model works, right? It generates the next word given a sequence of words. And as the sequence becomes longer, you have to compute all these conditional probabilities, and the computation becomes really expensive. Right? So the longer your prompt is, it becomes more expensive to OpenAI. So it has a limitation. You cannot put like entire book in ChatGPT and ask questions because it won't let you, right? Because it's too expensive for them to process, right? And as the sequence becomes long, these probabilities, these conditional probabilities becomes too small, and it gets lost and so on. So it becomes really difficult to process if your given sequence becomes long. Right? That's the one limitation. You cannot just increase it. And because of the language model, once it's trained, it doesn't get any more information. So it cannot be improved. I mean, there are other ways to improve it, like fine tuning. But basically, in order to make the model better, with the additional information, all you need to do, is you have to train the whole thing again, which takes months with millions of GPUs, a lot of power, a lot of data. You have to do it again if there is a new information comes in. So basically, large language models don't have memory, meaning once it's trained, that's it. Right? It doesn't get any new information. It is not able to get any more information. That stays as that. So whatever you interact with this large language model, these models don't memorize it, right? It will be lost once you close the window. Right? So there are, of course, some tricks that you can do. What they do is, okay, so you type something, right? Your prompt one, right? And the language model will generate its answer right here. Answer one. Then you do the next one, prompt two, and you see that this model actually has a memory of the first prompt and the answer, and it actually makes this conversation. It memorizes your conversation, but it's not memorizing. Actually, when you enter this prompt two, inside, what it does is it does prompt one combined with answer one, and combine that with prompt two, and it looks at all this long sequence. Right? That's how it memorizes your conversation. Right? It's not actually memorizing it. It's making the context longer. So get this answer two. Right? So you type something, prompt three. Well, that's actually not prompt three, right? It's going to be prompt one, answer one, prompt two, answer two, gets into the model with prompt three, and based on this long context, we're going to generate this answer. Right? That's why you cannot do this forever, right? It's going to forget at some point this prompt one, right? Because you cannot just increase the size of the sequence forever, right? So you say like it memorizes up to 20 conversations. Because that's how they do. Okay? So it basically does. So once you get this point, answer 20, it just forgets about the first one, right? Which is called memoryless. That's the language model's characteristic. And because of this, once it's trained, there is no way to feed into new information into the model. Once you start training, that's it. So say you start the training last year, June, your language model, the knowledge, stops at that point. Whatever happened after June last year, the language model doesn't know. There is no way to put the information into the model unless we create another one with that new information, which is too costly. So it just stops there, right? It's like a human who stops reading, going outside, and his knowledge stops at some point. This is what the language model is. And this is one of the biggest problems that language model does, is it says things. It's not makes sense, but it says things that are not correct. So I have to change this. things that are not correct. And this is the biggest problem that the large language model has. Because of the nature, it's just a probabilistic model that guesses the probability of word that comes after given sequence of word. That's what it does. So it doesn't know whatever it's saying is true or false. Right? It just has this probability of word. It just generates those. How can it know whatever it said is true or not? Because no one told them. Who told them whatever that sentence is true or false? Right? It doesn't know. So with very high confidence, it's going to say things that are not true, and it just doesn't know it's not true. It's called hallucination, and this is very difficult and critical problem that language models has. I mean, they're saying they're decreasing the probability of the model hallucinating, but still, it's not zero. So that's why you always have to check what the large language model says, because it doesn't know. There's no way to teach them what is true, what is false, and especially these language models are trained on the data on internet. And say if someone start to say Hawaii is in Asia, someone start to say Hawaii is right next to Korea, right? Someone says that sentence, and it became like a meme or something. Everyone start to say Hawaii is right next to Korea. So on the internet, there are like thousands of sentences saying Hawaii is right next to Korea, right? We all know that's not true, but because we can go back, look at the map, and check that's not true, right? Hawaii is not right next to Korea. 10 hours flight. It's a long way. But the language models, when they get trained, they'll see these sentences again and again, and it's going to be one of the sentences that will have a high probability of appearing in a document. So it's going to say that. We all know it's not true, just a meme, but computers doesn't know. So that's the problem there. And some of the limitations here, as it becomes larger, are overcome. So now this limitation 5 is not a problem. You start to understand the subtext, and it also start to understand the reason. The latest model from OpenAI start to reason. That's what they call. But some of the limitations, as the model becomes larger, we didn't do anything, but it just automatically disappeared. And there are a lot of people who are skeptical about this AI and large language models. And when we ask them, why do you think so? They usually say this here, because the data that we generate, humans are biased. So the data that we generate is biased. And if your model is trained on biased data, then your model will be biased, because that's what they see. Think about it. You have a child with the racist. I don't want to say this, but with the not. I don't want to go. But with the parents with a lot of biases, and the kid will learn those biases from their parents, and the kid will have a biases as well. So that's just exactly what happens to our large language model. It learns biases. And this, if you are in education, this is a big thing, right? The privacy. So it looks at all the things online, and you'll be surprised how much information, personal information, is online, and it's going to look at all those, and it actually learns them. Your social security number, if it's online, it's going to study that. I don't know, all the information about private information about people. If it's online, it's going to obviously going to learn them, right? That's a huge issue here, right? So what people do, to overcome these limitations, they do this fine tuning, but I don't want to go into details of this. But this is a one limitation that we can overcome. So the limitation number one, the large language model has a context length limits because of the computation difficulty as the sequence of word, the length of your prompt becomes larger, longer. It becomes a little bit more difficult to process them using language models. So this is one of the limitations that you probably experienced, right? So you like to put entire book, you say your textbook into ChatGPT, and you like to ask questions, write paper test, but it won't take you. Right? You cannot enter the whole book there. So GPT-4 supports 8,000 words, which is almost nothing. It's just like 20 pages. 232,000 tokens. You may think it's long, but if you think about it, it's not that long. So there's this limitation that we could overcome. So what we do, also here, this limitation actually makes some of the application really difficult, like legal contract are really long, medical histories, finance report, those reports are really long. So we like to process those documents using large language model. It becomes really difficult. So what do we do here? We came up with this retrieval augmented generation, RAG. We call it RAG, and this is how chatbots are. How we create chatbots using retrieval augmented generation. So we can just use the language model to create a chatbot, right? So you can just use ChatGPT as your chatbot, but the problem is if you just use your chatbot, it's going to have all those limitations of large language model. Right? So it's going to say things that are not correct. It's going to say things it's going to respond things that are private to someone. You cannot enter all the book in there and ask questions. So it has all the limitations of large language model if you use ChatGPT as it is. Okay? So what people do is they come up with this RAG. RAG enhances this large language model by retrieving external data before generating text. Okay? So when I teach this in my class, I tell my students that large language model is just a person who just learned language by reading thousands of books. That's all the person is. A large language model is just a person who knows only English. Nothing else. The person didn't study physics, the person didn't study biology, nothing. But of course, this person has read thousands of books. The person may have some knowledge about something that is in the books that he or she read, right? But think about it. If you're a person who read thousands of books, and you just stand here, if I ask you, okay, so the book 2324, who was the main character? You may be able to retrieve the information from the book that you read. You're probably likely to be either wrong or don't remember. Right? That's what large language model. You read so many books. If I ask you a specific question, it's not going to. I mean, it could be correct though if he remembers, but I mean, there's no guarantee that it's going to be correct. Okay? So what you do, Reg, in here is you are giving a textbook, say a physics book, to the person who just learned English, and I'm going to ask the person a question about physics. And what the person can do is the person can read the book because the person knows English, and the physics book will be written in English. It can take all the time in the world and just find the paragraph that is related to the question, and the person can answer it because the person can understand the paragraph and is able to generate this answer in English. So that's rare. We are basically giving the person who just knows English this textbook, so the person will be able to answer our questions on physics more accurately. That's what it does. Okay? So it prevents hallucination by coming up with the responses which has references. Okay? This is how it works. Process overview. It has an indexing of, so what it's going to do is going to cut the physics book into chapters or pieces, so you can look up easily, right? So it's going to cut the textbook into chapter 1, introduction to physics, chapter 2, I don't know, Newton physics, chapter 3, so on. So later when the person has to look up, so I asked him about quantum physics, he doesn't have to look through all the book. He just need to go to the chapter about quantum physics and look at the stuff there, and he can answer the question, right? So that's what it does. Indexing means split the documents, the textbook, into pieces, right? And store it somewhere so the person can look up. And the embedding here, this is the revolution of natural language processing. I have to talk about this here. So like a lot of you know this, I started my PhD 2011 as a computational linguistic, in computational linguistic field. That's my PhD area. And we did everything very manually. So if we want to know how happy a person is through their restaurant review using computer, you just need to generate the document, the list of vocabularies for happy word. So if people say like, okay, that's happy. If people say satisfied, that's happy. So what we do, we use this dictionary, and when you see a review, we count all the good word from the dictionary, and we count all the bad word from dictionary, and we sum them up. And if there are more positive words in your review, we used to say, oh, the person is happy. If there are more negative words in the review, we used to say the person is not happy, so on. That's what we used to do. And in 2000, I think it was 2012 or something, a group of researchers from Google Research published a paper. I think it's neither or Nature or Science. That's called distributed representation or something, and it just blew a lot of people's mind. They argued that using neural network, right, and you teach computer how the language is written from a bunch of documents, the computer is able to come up with this vector representation of each word by their meaning, right? So I first read the paper, and they say, oh, this is key. This vector right here, this arrow in 3D space, they say is king. And this vector actually captures the meaning of king. We don't know how the computer does it, but once the computer come up with this vector for king, that's what it means. And the computer also comes up with the vector for queen based on how these words are used in documents. And you can come up with the vector for man, and you can come up with the vector for woman. Right? What's so special about this? It's just a bunch of vectors for each word. Right? You can actually, what you can do with this is, since these vectors captures the meaning of word, you can subtract king you can subtract queen from king here, and it becomes this. Right? And that vector means so. Right? So same here. From man vector, you subtract woman from man, you get this. But as you can see, they are the same vectors, right? Starts at different place. So it probably means to this one. Has a meaning too. Right? That we can understand. So king, queen, what is the difference? Is gender. Man and woman, the difference is gender. So now we can understand this as a vector that represents gender. Okay? So you can do all this math, addition, subtraction of those vectors, and the product of those are vectors with meaning. It starts to become interesting. So I read this paper, and suddenly all my thesis topic changed, because this is like the revolution of natural language processing. Okay? So here, all these vectors represent capital of a nation, right? So you can subtract them, you can add them, you can do all those sort of things. And this is what it does. Indexing here splits your documents into pieces, and they vectorize each pieces as vectors. So if I draw a picture here, your physics book, all the chunks that talks about quantum physics will have similar vector like this. These are all the chunks or chapters or pieces of paragraph that talks about quantum physics. I don't know, like space, all here. So now you can represent this text as vectors by their meaning. If they are close to each other, they have a similar meaning. We can do them. So what you do in the beginning of where you come up with all these vectors, of course, and their associated text here, and you store that somewhere. Right? It's a vector database. If I type something, right, in Chatbot, your prompt, instead of putting that into a large language model, what it does is it vectorizes your prompt, and it's going to be somewhere here, right? And it's going to grab all these documents that are close to your prompt. Nothing with the large language model. This is just basic natural language processing. Right, so instead of answering using large language model in Chatbot, it grabs all these vectors that is around your prompt, right? And you can grab all this text as well, associated text, and you put it here. Okay, so according to this is this vector. Grab 10 paragraphs that are similar to my prompt here. Okay, and since it's in a database, I find their associated text. Say quantum physics is this, quantum physics this, quantum physics this. You'll have a case sentences or pieces. Now you enter this into your language model as context. Combine it with the prompt. What language model does is, instead of answering your question here from its knowledge, it looks at these 10 sentences and it looks at your answer or your question. Based on that, it's going to generate its response. Just like human, think about it. If I make my exam open book, you're not going to memorize everything, right? When you take the exam. The power bring your book. And if the question number 1 is about quantum physics, what you will do, you will look at all the chapters in the book about the quantum physics, read them, read the question, and come up with the answer. Right? You're not relying on your memory or large language models are, it's when the training stops, your knowledge is not updated anymore. So you can even put the latest information there that happened yesterday. To give this, since the language model is able to understand the language, it's going to come up with answer based on a bunch of sentences from the database with the language model's capability. It's going to create a lot more accurate answer than just using the ChatGPT as example. So what does it do? Your response can be up to date, right? Because you can store the latest information in your vector database, and your language model is going to look at those up to date information, so it can produce up to date responses. It prevents hallucination, right? Instead of answering the question based on your memory or whatever you learned, it looks at a bunch of list of sentences from your database and only look at those, and it will minimize the hallucination. And you can, of course, say your answers will come from trusted sources, so your answers are more credible, cost effective, instead of using long context. By putting entire book, the physics book, into a large language model will be costly. You don't have to do that. You just need to put 10 sentences that are most related to your question. This is very good. That's how people develop RAG. The Copilot, I'm not sure you guys have tried this or not. Is a very nice platform where you can build a custom chatbot without programming. Okay? So I use this over the summer with my students, but somehow a lot of things are done through Google, so we are not able to get license for Copilot Studio Pro. So I had to ask the people at Microsoft to give me a trial account. Unfortunately, that expired last month. So I tried to renew it. I met them last week, did everything to get it renewed. Somehow has a stronger relationship with Google than Microsoft, so I wasn't able to get it on time. But you can try this. So it's very easy. Here the link has it, but you just type Microsoft Copilot Studio. And if you have a license, of course, you can sign in and create the actual one, or you can try for free. And so if you click try for free, it will take you this, not this one. Try a demo. They actually give, if you are eligible, they actually give you a 3-month trial account. But you can do this. You can just demo it. So if you click it, it takes you to this website. So you need to enter the URL. What is this? This is indexing, right? In RAG. So you are providing the bunch of documents, like the textbook, that the large language model should use to answer the question. So you can put URLs there. Let me put UH Hilo College of Business and Economics, right? Grab the URL. So I'm just giving the chatbot where it can look up the question from. Say accept. This is quite good. Here, Hi, I'm a virtual assistant for hellohawaii.edu for College of Business and Economics. So I'll say, so it's not perfect, you will see, because it's just a trial demo. Who is Sukwa? Probably it's not going to answer. Oh, here's it. Sukwa is a assistant, so we need to update the web page. So Sukwa is an assistant professor specializing in data science and business administration at the College of Business and Economics. Let me look at my team. There's Todd. Todd is the director of college and so on. And since we have this vector database, it's not pulling the answer from its memory, the large language model. It has all these references. This is where the large language model is pulling its answers from, like this. You get these references. So it's very good. You can try it. It's fun to work with. Try this one. So this could be a one easy option to create your own chatbot. Of course, it's not free. Let's go. So here, detailed steps. You can find the manuals everywhere. You can even deploy the chatbot on your web page. And you can customize it by putting photos, name it. And here is the price. So it actually, so I want to show you the open source option, how much it costs, and these ones that you have to pay for. So Microsoft Copilot Studio, the monthly cost is $200, and it processes 25,000 messages per minute. So as soon as you get 25,001, it will charge you $400. Okay. So if your company is small enough, you think the people will not type more than 25,000 messages, this could be a very nice option because you don't need Python background, easy to make, right? And of course, you have to read all these fine prints. So that's a nice option too. There's another option too. I think a lot of you already know this. But in ChatGPT, it actually, so you just need to type custom ChatGPT using OpenAI. It will take you to this page, right? And it looks like a ChatGPT, right? So this is the screen that will see create. Hi, I'll help you build a new GPT. You can say something like, make a creative who helps generate a visual for new products. So I can make, I am creating a student advisor chatbot for my college. Okay. Okay, so here, primary role, things that you can put it there. I'll say all these steps here. Oh, here. Oh, no, not here. So this is the chatbot's response. Here, I need to put it here. I like to build a chatbot for my college advisor. It's creating. Okay. Now we need to come up with a name for the college advisor chatbot. I'll call it Maria. Okay. This generates pictures too. You can put anything there. So this is Maria. I don't know why they choose a, but yeah, okay, why not? Okay, so you make it email. And by the way, language models are able to understand the typos, spelling mistakes, because on the internet there are a bunch of typos. Yeah, so it looks good. So you can do this, right? So you can put all the information there. and create a chatbot. And you can share this with people. And of course, with the programming option, you have to pay for it. So you can only share this with the people who are already paying for ChatGPT, which is $20 to $25. So, but you can share that with anyone who has this paid plan. But that's something that you can do, of course. So sometimes it's cheaper to use these options. The last one that I'm going to share with you is, of course, the open source one, right? Free one. Everyone loves free, right? So why consider open source large language model? So not like Gemini, uh, ChatGPT. There are things like Llama. That's the one that I love, which is trained by the Facebook, the Meta, and we can use that for free, basically. I love Llama, and they just released 3.2 Llama that can process images, not just text. It also processes images. I think audio, I'm not sure. I haven't tried it. I tried the image one. It works really well. Of course, the text is really good. So it's basically free. You don't have to pay for it. Disadvantage, of course, is you need your own server to run the large language model, which could be really expensive because you need a GPU, a lot of GPUs. And of course, you have to program it, so it requires technical expertise, setting up and implementing it. So if you use OpenAI, so OpenAI also uh, supports this custom chatbot, not no programming option, but there is one that you can, this called API. A lot of you who are in computer science know this. You can use ChatGPT through API, and this is how much it costs to call one response. So there's all this price there, and it could be really expensive. Like here, the latest one, OpenAI O1 model is $15 for 1 million input tokens. So if you were to process a book using OpenAI, it costs you $15, which is not cheap. Right? It's quite expensive. So the free option, if I use Llama 3.1 for 100 users, you need a server. Let me see. You need a 31 H100 GPUs. The server has 31 100 GPUs, which comes out to be $930,000 for the server. If we want to do this in-house, as good as the ChatGPT. And I looked it up. UH system has 75,000 students, faculty, and staff, I think. I'm not sure the exact number. But if you use this number, you basically need what? $697,500,000 to service something that is similar to ChatGPT, which is I'll say very expensive. I don't think we can come up with this. But this could be an option. And if you are just making a chatbot for your students, say 20, 30 students, the computer that you have is good enough. That's what I'm going to show you. All right, so this here. So this is how you make reg chatbot. First thing is you need to create this vector database. So collect as many documents as possible, usually in PDF format, right? And vectorize it, come up with the vector representation of documents so you can look up. Okay. And let me show you one example. So this is the one that my students created over the summer this year. It's a chatbot. And I think I have that in my server. So this server at Halo, which cost me $3,000 only, has a 49 GPU, and I'm using small Llama model. And okay, so let me see. We have a two. So this is why so I didn't have a time to make it fancy and all. Okay, let's see. Oop, oop. Let me see. All right, so what I did, I teach this QBA 360 course, which is management science. So I use this book by Pearson, Introduction to Management Science. What I did is I have a PDF version of the textbook. And okay, so somehow I think I tried this in the morning, it worked, but yeah, so I don't think I can show you today, but here I put the entire textbook uh, in Chatbot, and I taught it, vectorize it, and I asked a question, what are the difference between linear programming and integer programming? And it comes up with answer here based on the provide experts. The main difference between linear programming and integer programming is that linear programming allows for continuous or fractional solutions, whereas integer programming restricts solutions to be integer values, which is what I would have responded to my students if they asked the same question. Okay? So here, what is the multiple solution in linear programming? When there are multiple optimal solutions, and you can see according to the provided context, multiple optimal solution is a linear programming refers to something. So this is what you usually see in Chatbot. But what I wanted to show you, server is not working, but was that you actually get a bunch of sentences from the book where it says linear programming. That's what rec does. So it just pulls up all the sentences that talks about linear programming from the textbook in the database, and it feeds all the sentences into large language model. In this case, is Llama 3.1. Okay, and what the large language model does is it reads all the sentences, and sometimes it's just nothing. Like even where in the reference it says linear programming, it pulls everything. It could be something that is related to your question, but sometimes it's not. So I want to show you, but you will see like a weird sentences. But what large language model does is it looks at them because it understands the English and like discard the ones that are not related to your question and use the ones that are related to the question. It actually makes those decisions and coming up with this really nice answer. And it also shows you how it came up with those answers. The page from a textbook, it used the passage from page 507, page 51, page 855, page 436, page 853. So if you want to check the answer, you can always go to the page and check yourself whether the answer is correct or not. Okay? So this is how you can overcome the limitation of large language model. This could be an example of chatbot. You can create an educational chatbot that I just did. So instead of hiring a TA, you can just create a chatbot and feed all your teaching materials in the chatbot so students can ask questions. And of course, it's going to be 24/7. So the students don't have to wait until the professor wakes up. Whatever they're doing their homework, they can just go to chatbot and ask questions without delay. And you can use that for research. So this is what I'm doing as a research through Change Hawaii project funded by NSF EPSCoR. We are trying to create a chatbot that will help us to do research better. Like, summarize the latest findings on machine learning in healthcare, and the chatbot will go over all the papers on machine learning in healthcare. It's going to summarize it and show you. So this is what we are trying to create in the project. And one last thing is you can also make your chatbot smart by giving it a memory. So large language models are memoryless. So it actually does not memorize or have a memory of user interaction, right? So whatever you type, it's going to memorize it just for 20 responses, but after that, it forgets whatever your interaction with the chatbot is. So what you can do is you have this memory, the interaction between you and the chatbot, and you store that in a database as well. This is what the user typed. These are the user information. You store them in a database. So when the chatbot, the large language model looks up the information in the database when it's creating its answer, you can actually look at the interactions between the user and the chatbot, and you can use that to generate a more personalized answer, of course. But the problem, of course, is that if it's your own chatbot, it won't be a problem. But if it's a chatbot that is a commercial company has created, that means it's going to store all your personal information, your interactions with the chatbot, and it's going to store that somewhere in their server. So that will be a privacy issue as well. So all this technology, if you want to make it better, smarter, you have to think about how it can balance the usability and the privacy issues as well. Okay? So that's all. And before I end, actually the chatbots, the Copilot, ChatGPT, and the Llama RAG was created, actually was tested by the students through the summer research program, 2024 Change AI summer research program. Students Jean, Jeanette, Basil. Here are their pictures. I got their permission to use their pictures here. And what we tried to do was we tried to create, so Helen here is our college student advisor. So we tried to create a chatbot named Helen that serves as a student advisor. That's what we tried to do over 6 weeks of period. Background of change. I'll skip this. And they showed it to students. Actually, we had a career fair event in summer, and we showed them the 3 chatbots from Copilot, ChatGPT, and our own custom chatbot, and ask for their opinions. And they say it's good, easy of use, it was efficient, and the information they got was comprehensive. And they actually liked the 5X one, their interactive experience. They actually liked interacting with the chatbot over interacting with the human. And they really loved it. And we tested. So here are like 20 very difficult questions that the student advisor usually get. And we ask chatbot number 1, Copilot, ChatGPT, and the Llama. We didn't have enough time to finish the 3rd one. So that's why the performance of that was low. But surprisingly, it was really smart. So the questions here are easy ones, but we even asked the questions like, I'm a student in finance major, and I work Tuesday and Thursdays part-time from 9 a.m. to 2 p.m. And I'm a senior, so I need to take all the 400 level courses in finance. Based on the schedule in fall this year, can you recommend a list of courses that I can take that does not conflict with my work schedule? And the chatbot was able to pull up all the information regarding the schedule, the program requirement, and they look at the timetables as well. It was able to create the schedule for the students as well. So actually, the presentation is on YouTube. You can go look at it, and that's all. So I'll take questions if there are any. I hope you guys enjoy the presentation. Hey, I know it's a lot of work. I can take any question. So it doesn't have to be about the presentation, but if you have questions about language model, chatbot, AI, anything, then I'm happy to answer the questions. Okay.
Question in the chat saying, will you share a
I can share that. Of course, it's not on GitHub because that's what the student has made. But I can ask the student, or they can share the script with you or not. Just email me and I'll connect you to the student. Any other questions? I don't know. It's not working. Used to work. Morning. Hey. Yeah.
the option is to include a link to a website?
Yep.
Is there any option to upload a document?
Yes. So there are. So that was demo. So it has a limited capabilities, but if you use the actual Copilot Studio Pro, create a chatbot, there are multiple ways to teach it. One will be a link, and they are quite smart. I think both of the OpenAI and Microsoft, they're smart. If you give a link to the chatbot, it does not only study that web page, but it actually goes down the level. Like, like in HTML, you can add something to end of your URL and goes the level below. Last time they don't explicitly say it, but last time I checked it, they can go as low as 3 levels. So it actually pulls up everything underneath the web page and studies it. And of course, you can put PDF, and they call it knowledge. So you can put Word document, PDF, even Excel files there, and it's going to study those. I think for both of them, yeah, Chatbot and ChatGPT and Copilot. But with custom Chatbot, you can input anything. Yeah, there's no limitations there. Okay. Yep.
I have a question.
Yeah.
So, um, in our group, we have a bunch of like health tickets, and I think we were wanting to maybe like categorize the tickets based off of like subject. What is a like what would be a strategy to kind of like can you like would something like this be?
Yep. So if there are just a few categories of tickets, then you can put that in a context. So when you are using the chatbot, you can say, this category A is this, category B is this. You give the definition of those categories, and based on these categories, how can you categorize whatever you just typed? And it's going to do that for you. So you don't even need this vector database to look up the information. If it's long, of course, you need to create this vector database so Chatbot can pull up the information. Or you can just embed it in the context. It's like you are entering things in the ChatGPT. Put all the categories in there and your ticket, and the ChatGPT will classify for you.
Would you need to like define like keywords for it to kind of pull?
So language models are really smart. You can just describe it. So I have this task, I have 5 categories. One is student related, one is faculty related, one is staff related. You just have to be DEFEC. And can you categorize whatever this ticket to one of those categories? You will be able to do. But more, of course, is the conditional probability. That's why I try to cover all these technical details. But as the more information you provide, it's going to give you more information. Well,
Have you tried the AI, Google AI Studio?
Yeah, so Gemini, I do have a lot of friends who works Google, so they actually asked me to use it for even for this workshop too. But it's not that friendly, I'll say. I have to use their own platform. So that's their. I'm comfortable with Python and open source. I think everything should be free, shared with everyone. So I actually don't like those big companies APIs, but Gemini is really good. I have to try, so I tried it. I'm not using it, but yeah, I'll say it's very good. But I think OpenAI can feel it's better. It depends on you, whatever task you do. Everyone says theirs is better than yours. So. Yeah, but I think UH is we're using the Google suite, so it's a lot easier to use Google Gemini.
Yeah, I'm gonna try it because in fact I do have a license for advanced Gemini.
Oh yeah.
So it comes with the AI Studio, but I haven't had a chance to.
So I think their philosophy I think is different. So OpenAI they focus more on non-programming options. So they focus more on ChatGPT, that you don't have to program. But Gemini, I think they are more friendly to the computer programmers. So yeah, if you're a developer, I think Google Gemini is the option. But Microsoft, they are crazy about non-programming options because that's what people want, right? A lot of people want that. Yep. Thank you, everyone.
So much. If you have any questions.
If you can.
Thank you.